So we're going to read in as a binary file, and we can write output as a binary file instead of text files. So data stored in a text file is for human read, but in reality, text file process too much because you have to convert back to human read, and you also have to convert again to write to the text. In reality, JVM or computer is only write and read binary files. So if you do process between one computers, you don't really need to write and read a text file. It makes it more efficient. So, but the negative thing about doing that is human cannot read the binary files. So if there's something wrong, then you can't even keep tracking by opening the file and try to read it. So example is Java source program is a text file that you write a code, can be read by text editor and humans, but Java classes store it as a binary files as a .class format and read by the JVM. So advantage of binary file is that they are more efficient to process than text files. So that's why when you write a program, you pretty much like to do binary file if you not do a report for human to read. So we look at how the input-output with the binary file is processed compared to the text file here. So when you use that binary file, you have to look at file input stream and file output stream class. And let's deal with the bytes. When we read and write primitive values and string using the data input stream and data output stream, this is for primitive values. And to store and restore object using, if you want to write the whole object, right, and read the whole object, you have to use object output stream and output object input stream, and to understand how objects are serialized. So when you're dealing with writing the whole object, like if I want to write a student class must be serializable. Implement the interface serializable. Like for example, if I have like circle class, if I want to write a whole circle class, it has to implement serializable in order to write that as an object. Now circle can be write to the stream as a binary file using the object output stream. So implement serializable interface to make objects serializable. It's just marked just like mark it as clonable. Same concept, mark it as I can read and write this as a binary file. So to serialize arrays, you can do that too. The whole array can be serialized. And to read and write the whole arrays to the binary files. So to read and write the same file using the random access file class. So the random access file class, you can see this on the test. You see a lot of questions on this too. So this is like if I want to access like a location of the files randomly, you can just use this class to help. Now we talk about to read in right from the files is also always in the binary format and as well as output, right? So before we use scanner to read in, and we use print writer to write. So we can look at text file and binary files here, right? Like I said, if you're dealing with text files, data stored in the text are represented for human to read, right? If you're dealing with text, right, although it's not technically precise and correct, you can imagine that a text file consists of a sequence of characters, and a binary file consists of a sequence of bits. Like for example, the decimal integer 199 stored as a sequence of 3 characters 199. It's always characters. In the text file, and the same integer is stored as a byte in the binary file. So in the binary, it's going to be you convert this into ASCII code, and it's binary as C7. course, the decimal of 199 is actually hexadecimal C7. Let's convert to hexadecimal. This is for the number, but for the letters A, B, C, use ASCII table. So this is an example. So this is text file. So when you're dealing with text file, you have to process encoding and decoding right into binaries here and decode back. But when you're dealing with BinaryIO, you don't have to do encode and decode. You can just write in that C7 and read back as C7. Right? So encode decode, that is just represented 199 code. It's just for human to read. But when you start with binary, you can start C7. So now let's look at the BinaryIO classes. So we have object is a root. We have input stream, and output stream extends from object. Input stream, like we said, if you're dealing with a file, we're dealing with file input stream, filter input stream, object input stream. And filter input stream, if we just do data input stream, buffer input stream. So go back to this, right? Data input stream used for a primitive data type. File input stream is for the file like the byte size. So that's why we have the hierarchy here. If you're dealing with the whole object, you use object input stream. If you're dealing with a primitive data type, you use data input stream. If you're dealing with data bytes on files, then use file input stream. Same as the output streams. So input stream. So let's look at a class named input stream. This is the parent of all the other classes. So we have read. We can read by bytes, read by bytes, and set and offset. An array. I mean, this is the array of bytes, right? Read an array, return ints, right? So the stream has been reached. Right, end of the stream has been reached. It's going to return -1. You keep reading until end of streams or end of the file. So you can specify offset to read from the array. You don't have to read the whole array, but provide a specified index to read. And we return the number of bytes from the variables that can be read from input stream. So like I said, whenever you open, you want to close it, just like text, right? Scanner.close, printwriter.close. When you're dealing with the file system, you want to close that. You can skip, right? Discard, skip over and discard bytes of data from the input stream. Mark supported. Test if this input stream supports the mark and reset methods. And mark the current position in the input stream by passing the current position. Reset. Right, so reposition this stream to the position at the time the mark method was last called. Output stream, that means we write. We can write the values of byte. We can write the arrays of bytes. We can write at specify offsets of the arrays. Don't have to be the whole arrays. You can close that after write. Flush, that means flush this output stream and force any buffer output bytes to be written out. So pretty much just like clean it from the memories. So now when you're dealing with the file, we use file input stream and file output stream. So this asserts a binary input and output stream, right? With an external file. All the methods in file input stream and file output stream are entered from the superclass input stream and output stream that we just seen. To construct a file input stream, you're going to say file input stream and pass in the name. That's one way, just like the way that we use scanner and printwriter. Right, this file name or the file type, right? And one thing that we have to do is the file exception. It's just type check to make sure that the file was existing before you're writing and reading. So file output stream. To construct a file output stream, then you just do constructor name and file, or you can just do file name and. So the difference is, if you want to output mean you write to the file. If you want it to be append, you don't want it to overwrite the original one, then you can set boolean append to true or false. Because by default, I think it's going to overwrite. So if you want to set it to true, it's going to append. It's not overwriting, like the log files. You keep typing on the log, you want to append. So let's look at the code. Right, so how to use this, just define the file type. So since this is the binary file, so we just do .dat, stand for data. That's file output stream. And the same, just do output.write. So this is going to write the values I to the file. And just want to read it back, just do the same. Create input stream, specify file name, and iterate it until no more to read in, right? If it's read as -1, that means end of the file stream. So when you run that, it's pretty much just takes the file stream and it's read back after it read the number 1 to 10 back. So this is like reading and writing as the bytes. So now let's look at filter input stream and filter output stream. Filter streams are streams that filter bytes for some purpose. The basic byte input stream provides a read method that can only be used for reading bytes. If you want to read integers, doubles, strings, you need a filter class to wrap a byte input stream. See that? So like I said, file input stream, file output stream, just dealing with the bytes. But now if you want to deal with a primitive type, you have to deal with filter input stream. To wrap the byte input stream, right? Using a filter classes enable you to read integers, doubles, strings instead of bytes and characters. So filter input stream and filter output stream are the best classes for filtering data. When you need to process primitive numeric types we said we want you to use their input stream and their output stream to process the type primitive data types, because they extend from filter input stream and filter output stream, right? Their input stream, their output stream. So data input stream reads bytes from the stream and converts them into appropriate primitive type values or strings. Data output stream convert primitive types values or string into bytes and output the bytes to the string. So this is just UML to represent the methods of that. So data input stream extend the filter input stream. We already seen that in the hierarchy, right? So we have the method, right? Implements the data input interface. So we have an interface for data input. So this is hierarchy, but it also implements this. So that means it has to override the method read boolean, read byte, read char, and so on. These are primitive type. Same as the output, so we can write by boolean, write by byte, and so on. So characters and string in BinaryIO. A Unicode consists of 2 bytes, right? So this is Unicode to represent any alphabetical in the world, right? So we have write char, write the Unicode of character C to the output. We have write char and string method write the Unicode for each characters in the string S to the output. So we have UTF-8 is a coding schema that allows system to operate with both ASCII and Unicode efficiently. ASCII is 7 bits. Most operating systems use ASCII, like Java code use Unicode. The ASCII characters set is a subset of the Unicode character set, since most applications need only the ASCII character set.